Hello everyone. On this video we will be looking at solving problems using the chain rule. Okay, so let's get a general idea of what the chain rule is. Let's say if y equals some function that we will call u, and it is a differentiable function, and if we also know that u is some function of x. Okay, so in other words, y is equal to some function inside of a function. Okay, so if we're assuming that g of x is a differentiable function of x, then it's safe to assume that the derivative of f of g of x is it equal to f prime of g of x times g prime of x. Okay, and this is what we call the chain rule. Okay, or another way to write it would be y is equal to some function of u, where the derivative is derivative of y with respect to u times derivative of u with respect to x. Actually, we will use this when we talk about implicit differentiation. Okay, so this will be seen on implicit differentiation. Okay, it's the same general idea as the chain rule, but we'll go into more detail on that when we reach implicit differentiation. Okay, now we're going to go ahead and prove that this is the case, that the chain rule formula is true. Okay, so what if we know that y is equal to f of g of x? Okay, now if you remember, if you want to find your limit function, let's say we have h prime of c is equal to the limit of f of x minus f of c all over x minus c as x approaches c. Now that's just your limit formula for derivative. Okay, so if y is equal to f of g of x, then that means the derivative is equal to the limit of f of g of x minus f of g of c all over x minus c as x approaches c. Okay. Now what we're going to do with this is we're going to multiply it by g of x minus g of c over g of x minus g of c. At least in the numerator, that's what we're going to do. So I should point that up. Alright. So what that does is it will give us the limit as x approaches c f of g of x minus f of g of c all over x minus c. Oh, made that a little too long. Time, actually, should wait because I'm going to multiply that. G of x minus g of c over g of x minus g of c. And now we'll close it up. Alright, so if you remember, you can go ahead and distribute that limit to both of those factors. So that's the limit as x approaches c, f of g of x minus f of g of c all over x minus c times the limit of g of x minus g of c all over x minus c. Oh, g of x minus g of c. That's right. I've cleaned that up a little bit. G of x minus g of c. There we go. X minus c. Kind of mix that up a little bit. Okay, so what we did, we actually just swapped these two denominators. Okay, so g of x minus, because it's multiplication, you can go ahead and just switch those right on out. So that's what we did there. Alright, so what does that give us? This is the formula for f prime of g of c. And this is the definition of g prime of c, which gives us our definition. Alright. So if you are still writing, feel free to press pause, but we're going to jump right into our first example. Okay, so let's say, for example, you want to find the derivative of, say, h of x is equal to 3x minus 2x squared to the third power. Alright. So for this one, this is where you want to remember the chain rule. F prime of g of x times g prime of x. Alright, so in this case, inside of here is your g of x. Okay, so h of x equals 3x minus 2x squared to the third power. This is your g of x. Okay, so that means your derivative is equal to the derivative of the entire function. So what we're going to do is we're going to just take down that exponent and use the power rule. We're going to bring down that 3 and then subtract 1. So it's going to be 3 times 3x minus 2x squared, then subtract 1, and then take the derivative of what's inside. So that's times the derivative of 3x minus 2x squared. So clean that 2 up a little bit. Okay, so what that gives us is 3 times 3x minus 2x squared times the derivative of 3x is 3, and the derivative of negative 2x squared, bring down that 2, is just minus 4x. Okay, so this would actually be our derivative, or you can write it as 3 times 3 minus 4x times 3x minus 2x squared squared. Alright, so there's actually another way you can do this. It's called Usubstitution. Okay, so what if we just the same problem? Find the derivative of h of x equals 3x minus 2x squared to the third power, Usubstitution. Okay, so this one, we let u equals what's inside of there. 3x minus 2x squared. So the derivative of u with respect to x is equal to, find the derivative of that is 3 minus 4x, so we did it up there. Okay, so if you remember, derivative of h with respect to x is equal to derivative of h with respect to u times derivative of u with respect to x. Okay? So, we know that our h of x, since this is equal to u, this will now be u to the third power. So h of x equals u to the third power. So really all we did is just make the inside equal to u. That's how we got u to the third power. Okay, so derivative of h with respect to x is equal to 3u squared times, well, derivative of h with respect to u times derivative of u with respect to x. Okay, so derivative of u with respect to x is 3 minus 4x. Okay, so see here, we have our derivative of h with respect to u and derivative of u with respect to x. Okay, so that means your derivative of h with respect to x is equal to, once we replace our u with what it is 3 times 3x minus 2x squared times 3 minus 4x. Okay, so we get the exact same answer, just two different methods. All right, so if you are still writing, feel free to press pause. We're going to go ahead and move on to our next example. Okay, so hopefully after a couple of examples, the pattern will start to make sense. So what if we wanted to find the derivative for h of x is equal to x squared plus 1 to the fourth power? Okay, so once again, we remember our chain rule. Derivative is equal to f prime of g of x times g prime of x. Okay, so your g of x is always what's inside. That's your g of x. Okay, so that means your derivative is equal to, we do the exponent of the the power rule. Bring down the 4 and subtract 1. So you have 4 times x squared plus 1. And we subtract 1. And then we get the derivative of what's inside. Okay, so remember, we take the derivative of the whole thing, and then we take the derivative of what's inside. Okay, so that's going to equal 4x squared plus 1, and we subtract 1, so that's to the third power, times the derivative of x squared, bring down to 2, so that's 2x. The derivative of 1 is just 0, so that leaves that there. Okay, and here we can go ahead and combine the 4 and the 2. So that's 4 times 2 is 8, so you have 8x times x squared plus 1 to the third power. Alright, so let's go ahead and do another example. What if we wanted to find the derivative for h of x is equal to negative 2x squared minus 2x plus 3 to the fifth power. Okay, so just like before, we know our derivative for the chain rule is equal to f prime of g prime of x, f prime of g of x times g prime of x. Sorry about that. Clean that up just a smidgen. There we go. Okay. So remember, what's inside is our g of x. So h prime of x is equal to, we take the function, the derivative of the whole thing, so we just bring down the 5 times negative 2x squared minus 2x plus 3. We subtract 1. Then we multiply that by the derivative of the inside. Negative 2x squared minus 2x plus 3. Okay, so that gives us 5 times negative 2x squared minus 2x plus 3 to the fourth power times derivative of negative 2x squared. If we bring down a 2, negative 2 times 2 is 4 times x minus the derivative of negative 2x is just 2, so we have minus 2. And derivative of 3 is just 0, so that disappears. Okay, so you can go ahead if you want. If you want to leave it like this, you can, or if you want to switch it around, you can do that also. Alright. So if you are still writing, feel free to press pause. We're going to go ahead and move on to our next example. Okay, so what if it looks a little bit different? What if we wanted to find the derivative of h of x is equal to the cube root of x squared minus 1 squared? Alright, so whenever you have these square root or cube root or any root functions, it's usually easier to just rewrite it. Okay, so we rewrite it. So h of x equals the cube root of x squared minus 1 squared. That will now become, let me make that 3 a little bit smaller. Looks a little odd being that big. There we go. It'll be h of x equals x squared minus 1, and make that to the 1/3, because remember, the cube root of x is equal x to the 1/3 power. So if you have the 1/3 power minus that 2 that's already in the exponent, that'll give you x to the 2/3 power. Okay, so if we didn't have that squared there, it would just be to the 1/3 power. But because that squared is there, we have to multiply that 1/3 by that exponent that's already there. So that's how you got your 2/3. Okay, so now we find the derivative of this using our chain rule. So h prime of x is equal to, we bring down that exponent, 2/3 x squared minus 1 to the 2/3 minus 1 times the derivative of what's inside. Okay, and once again, the derivative of the whole thing times the derivative of what's inside. So that's why we found the derivative of the whole thing and the derivative of what's inside. All right. Okay, so we go ahead and simplify this. So that's going to equal 2/3 times x squared minus 1 to the negative 1/3 power times the derivative of x squared minus 1 is just 2x, and that minus 1 becomes 0. Okay, so you can go ahead and simplify this by multiplying these two together. So you have 4/3x times x squared minus 1 to the negative 1/3 power. Or, because you have that negative exponent there, you can make that 4x over 3 times the cube root. And move that over a little bit so it's not right next to each other. So you have 3 times the cube root of x squared minus 1. Alright, so if you are still writing, feel free to press pause. I'm going to go ahead and look at another example that, once again, is a little bit different. Okay, so what if we wanted to find the derivative for h of x is equal to negative 7 over 2x minus 3 squared. Alright. So what we're going to do now is, just like before, we're going to rewrite it. Okay, so we're going to rewrite it. So you have negative 7 over 2x minus 3 squared. And instead, you're going to just rewrite that as negative 7 times 2x minus 3 to the negative 2 power. Alright, this way you can go ahead and use the chain rule easily. Okay, so our derivative, our h prime of x, is equal to, this is our h of x. We take the derivative of the entire thing, so we bring down the negative 2. So we have negative 7 times negative 2 times 2x minus 3. And we subtract 1 from there. Times the derivative of what's inside, 2x minus 3. Okay, so if we go ahead and combine those two, we have negative times negative is positive, so we have 14 times 2x minus 3, negative 2 minus 1 is negative 3, times the derivative of 2x, which is just 2. And derivative of negative 3 is 0, so that's that. Okay, so if we go ahead and just combine those two, we have 28 times 2x minus 3 to the negative 3 power. Or we have 28 over 2x minus 3 to the third power. Okay, so hopefully the pattern's starting to make sense. Okay, so let's look at another one. Okay, if you're still writing, feel free to press pause. We're going to go ahead and move to our next one. Okay, so what if we wanted to find the derivative for h of x is equal to 3x minus 1 over x squared plus 3 squared. Clean that up a little. X squared plus 3. Alright. Okay. So now what we have to do is we have to find the derivative of the whole thing. So h prime of x is equal to, bring down that 2, times 3x minus 1 over x squared plus 3, 2 minus 1, times the derivative of what's inside, of 3x minus 1 over x squared plus 3. Okay. Now this one's not going to be quite as quick and short as the previous one. Okay, because you're using, for the derivative of this one, you're using the quotient rule. Okay. So if we go ahead and simplify this, I'm going to move it over to the left because it's going to get a little bit lengthy. So I'm just going to move my equal sign over. So you have 2 times 3x minus 1 over x squared plus 3 to 2 minus 1. So that's just the first power, so you don't have to put the 1 there. Times the derivative of this quotient here. So if you remember your quotient rule, it's your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. And kind of block that off a little bit. Alright, so we can go ahead and simplify those terms. We have 2 times 3x minus 1 times x squared plus 3 times, we have x squared plus 3 times the derivative of 3x is just 3. Derivative of 1 is 0, so that's just 3. Minus your 3x minus 1 times the derivative of x squared is 2x. And derivative of 3 is just 0, so that stays there. All over x squared plus 3 squared. Alright, so we can go ahead and distribute those to get rid of those parentheses up there. Kind of simplify it a little bit. Okay, so we have 2 times 3x minus 1 over x squared plus 3. 3 times x squared is 3x squared plus 9 minus 6x squared plus 2x all over x squared plus 3 squared. Alright, so once we go ahead and combine those two, we end up with 2. We can actually separate these, so you have 3x minus 1 times 3x squared minus 6x squared is negative 3x squared plus 2x plus 9 all over, you have x squared plus 3 squared, and you have x squared plus 3 over here, so that's x squared plus 3 to the third power. Okay, so it wasn't as short and quick as the other ones, but it wasn't horribly bad. Took a little extra work. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Alright, so just to mix it up a little bit, what if we know that h of x is equal to 2x minus 3 to the 6th power? So we want to find the second derivative of h. Okay. Now the only difference is you're going to apply the chain rule twice. The only difference. Everything else is exactly the same. Okay. So we want to find our first derivative. We take the derivative of the whole thing, so we bring down the 6 times 2x minus 3, then we subtract 1, then we multiply that by the derivative of the inside. Alright, so what does that give us? That gives us 6 times 2x minus 3 to the 5th power times the derivative of 2x is just 2. And derivative of 3 is 0, so that's all we have. So if we go ahead and combine those two, the 6 and the 2, we have our first derivative is equal to 12 times 2x minus 3 to the 5th power. Okay. And from there, we know that to find our second derivative, that's just the derivative of our first derivative. Alright, so that means it's our derivative of 12 times 2x minus 3 to the 5th power. Okay, so once again, we go ahead and move that over a little bit so we can have enough room. Find the derivative of that, so we have 12 times the derivative of 2x minus 3 to the 5th, so we bring down the 5, times 2x minus 3, then we subtract 1, times the derivative of what's inside, which is 2x minus 3. Okay, so that's going to equal 12 times 5 times 2x minus 3 to the 5 minus 1, which is 4, times the derivative of 2x minus 3. The derivative of 2x is just 2, and derivative of 3 is 0, so that leaves it with just 2. So once we multiply the 12, the 5, and the 2, we see that our second derivative is equal to 120 times 2x minus 3 to the 4th power. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. So let's say, for example, if we are given that h of x is equal to 4x squared plus 9 to the 6th power, let's say if we want to find our second derivative of that. Okay, so what I want you to do is I want you to press pause and try to find this one on your own. Alright, so I'm assuming you've pressed pause and you've already worked this one out. So let's go ahead and verify your answer. Okay, so first we find our first derivative. Okay, so we take the derivative of the whole thing. So we bring down our 6. 6 times 4x squared plus 9. And we subtract 1, the 6 minus 1 power, times the derivative of what's inside. 4x squared plus 9. Alright, so that means our first derivative is equal to 6 times 4x squared plus 9 to the 5th power times the derivative of 4x squared, bring down the 2, that will give us 8x. And the derivative of 9 is 0, so that disappears. So if you go ahead and combine those two, we see that our answer is, for our first derivative, is 48x times 4x squared plus 9 to the 5th power. Okay, so now to find our second derivative, we apply our product rule because you have two x functions that you're trying to find the derivative of. Okay, so your second derivative, remember that's the first, times the derivative of the second. Plus your second times the derivative of the first. Alright, so what does that give us? That gives us 48x times, now we have to apply the chain rule in here. Okay, so we bring down the 5 times 4x squared plus 9. Then we subtract 1, so 5 minus 1 is 4, times the derivative of what's inside. 4x squared plus 9. Okay, plus we have 4x squared plus 9 to the 5th power times the derivative of 48x, which is just 48. Okay, so it can get a little bit tricky, but as long as you stay with the correct concept, you should be okay. It takes a little bit of practice sometimes. Okay, so that gives us 48x times 5 times 4x squared plus 9 to the 4th power times the derivative of 4x squared plus 9, the derivative of 4x squared, bring down the 2, that gives us 8x. And the derivative of 9 is just 0. So that's plus, you have the 4x squared plus 9 to the 5th power times 48. And close that up. And there we go, just to make that nice and together. Alright, so if you notice here, both of these terms have a 48. And you have 4x squared plus 9 to the 4th and 4x squared plus 9 to the 5th. So you can actually factor out 48 and 4x squared plus 9 to the 5th power. Alright, so what does that give you? That gives you 48 times 4x squared plus 9 up to the 4th power. Sorry about that, because that one's only 4, that one's 5th, so we can only factor out a 4th. 48 9 to the 4th power times, here you have your x and 8x and 5. We're going to go ahead and combine those three, which gives us 40x squared. So you have 40x squared times 4x squared plus 9. So plus 4x squared plus 9, sorry about that. Because we factored that out, that leaves us plus 4x squared plus 9. There we go. And this is why, I'm trying not to do this, but it really helps to avoid mistakes. When you factor something out, draw a little line through it. And then this one, you can draw that out and just make it to the 1st power. Other than that, this way you won't have to worry about making the error that I almost made. So whenever you factor something out, draw a little line through it just to kind of remind yourself that you already factored it out. Okay? It's no guarantee that, it'll avoid mistakes, but that little gesture really does help sometimes, just with those little things. Alright? So, if we combine these two, you have 48 times 4x squared plus 9 to the 4th power times 44x squared plus 9. Alright, so this one was a little bit tricky. Okay, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our last example. And it's pretty much like this one. Okay. Okay, so it's given that h of x is equal to 6x squared plus 4 to the 6th power. You want to find your second derivative. Okay, so just like before, I want you to go ahead and press pause and try to find this one on your own. Alright, so I'm assuming that you've done this one. So let's go ahead and jump right into it and verify your answer. Okay, so first we find our first derivative. So we find the derivative of the whole thing. So we bring down the 6. 6x squared plus 4. Then we subtract 1. So to the 5th power times the derivative of what's inside. 6x squared plus 4. Okay, so that is going to equal 6 times 6x squared plus 4 to the 5th power times the derivative of 6x squared. If we bring down the 2, that gives us 12x, and derivative of 4 is 0, so that stays the same. Okay, so if we go ahead and combine those two, we have 6 times 12, which is 72x. So our first derivative is equal to 72x times 6x squared plus 4 to the 5th power. Okay, so once again, we go ahead and use the product rule because we have two functions multiplied to each other. Okay, so to find our second derivative, we have our first 72x times the derivative of the second plus the second times the derivative of the first. There, the first times the derivative of the second plus the second times the derivative of the first. All right, so that gives us 72x times the derivative using the chain rule for this one. We have our 5 we're going to bring down, so we're at 5. Actually, let me use the brackets so it's not a bunch of parentheses lying around. So we have 5 times 6x squared plus 4 to the 5 minus 1, which is to the 4th power, times the derivative of what's inside, which is 6x squared plus 4. Plus 6x squared plus 4 to the 5th power times the derivative of 72x, which is just 72. All right. So what does that give us? That gives us 72x times 5 times 6x squared plus 4 to the 4th power. Derivative of 6x squared, if we bring down the 2, that's 12x. Plus, we have our 6x squared plus 4 to the 5th power times 72. Okay, so just like before, we're going to factor out 72 and 6x squared plus 4 to the 4th power. Okay, so if we factor out the 72, we have 72 and 6x squared plus 4 to the 4th power. Again, go ahead and cross that out. Crossed out our 72 since we factored those out. That will be times 5 times 12x times x is 60x squared plus our 6x squared plus 4. Okay, so once we go ahead and combine those two terms, we end up with, bring that up a little bit, 72 times 6x squared plus 4 to the 4th power times 66x squared plus 4 as our second derivative. Okay. Now, the last two examples were really just examples of when it can get complicated. Okay. It doesn't usually get too complicated, but it can get a little tricky like this one. Okay, so that was just to show you how to approach it if you did run across one that was a little bit complicated. All right. So hopefully this made sense, and I will see you on the next video.